Good morning, everyone. I would thank you for giving us the opportunity to present our work titled Blockchain-Based Solar Energy Trading. Throughout this presentation, I will be following this outline, starting with introduction, which will cover the purpose and overview of our work. Then I would be briefing one by one the key terms related to our work: energy internet, blockchain, smart grid, implementation approach, the requirement analysis, and then finishing with the conclusion. Depletion of non-renewable energy resources is having an adverse effect on the planet. Therefore, various governments have begun enforcing use of renewable energy to meet the rising electricity demands. Due to environmental and resiliency benefits, distributed energy resources are a potential solution for meeting future electricity demand. The survey provides a concise review of smart grid, blockchain architecture, and their role in distributed energy trading. Solar energy has been the primary focus as the renewable energy resource for implementation purposes. Energy Internet is a combination of electric power and internet technology, where energy flows from suppliers to customers like data packets do in the internet. The Energy Internet proves beneficial in terms of development of a new business model because of the flexibility introduced in power exchanges and lower energy cost, improved system reliability due to balancing of variable loads, increased energy efficiency and optimized energy management system due to reduction of power loss, faster information and communication, planning and energy telemetry technologies. Blockchain is basically a distributed ledger which spans over a blockchain network. The more number of participants in this network, the blockchain network becomes more secure. Since the blockchain has a distributed structure and numerous levels of verification, the participation trust among the participants increases. Few examples of blockchain are Ethereum, Fabric, Corda, and Quorum. Smart grids are a network of producers and the consumers. Producers are the distributed sources of renewable power, whereas the consumers are the ones who would use the power from the smart grid. Producers add energy to the network by selling it in the market, whereas the consumers access it from the network by using it after buying from the virtual medium. Here is the comparison of traditional methods and the smart grid. In traditional models, we have a centralized structure. In smart grids, we have a decentralized structure, including the large-scale power plants as well as the small-sized power generators. Power source for the traditional models are mostly hydrocarbons. In smart grids, we fulfill our energy demand from the renewable energy. In traditional models, consumers buy power from energy companies, which is a one-directional transaction. In smart grid, it can be a multi-direction transaction, that is, among the providers and the consumers. In traditional models, the pricing is governed by the government or the power companies. In smart grids, every generator can set their price. The billing method in the traditional model is postpaid. In smart grids, we have a prepaid method. This is the representation of power monitoring in the smart grid. Smart meters help monitor transfer of electricity in the main grid. The availability of power in the energy markets can be monitored with this apparatus, which further affects the pricing mechanism. This is the overall representation of the smart grid. It includes the physical layer and the virtual layer. The networking and the structure of the grid connection can be done as per the uses and requirements. Grid connection and network comprise the physical aspects of the grid. Virtual layer contains the pricing mechanism and the interfaces. Energy markets need to moderate the trading process with localizing methods like the non-cooperative game theory models or the ECO trading algorithm. There are constraints to monitor sufficient supply of energy to balance the demand and supply in the market. The implementation approach comprises of the physical layer where the actual energy trade happens, the blockchain which secures the transaction, and the marketplace where the pricing mechanism works. These are the required components for implementing an energy trade setup. survey about blockchain and how it can aid carry out transactions in the smart grid, enhancing the energy internet has been carried out. Several smart grid structures and the respective constraints to be taken into consideration while implementing have been studied as well. Thank you.